Today we are going to talk about a fundamental data type called integer. We have various data types to study, and today we begin our session with integer data type. Recall from lecture 3, that is Introduction to Variables. Integer can take either 2 bytes of memory space or 4 bytes of memory space depending upon the machine you are working with. As we know, 1 byte is equals to 8 bits, therefore 2 bytes is equals to 16 bits and 4 bytes is equals to 32 bits. More the size, more content it can hold. Obviously, if you want to know the size of integer programmatically, then you can by using sizeof operator. Sizeof is a unary operator that helps us in determining the size of any data type that we provide to it. As you can see here in my computer, size of integer is actually equal to 4 bytes, as the output is 4 of this sizeof. I provided the output with the help of this printf function. Note, sizeof is a unary operator and not a function. You might think of it as a function, but it is not a function. Now let's define range. Range is nothing but upper and lower limit of some set of data. For example, here you can see this set consists of some values 0, 1, 2, 3, and 4. If you want to determine the range of this set of data, then you have to determine the minimum value as well as the maximum value. Here you can see the minimum value is 0 and the maximum value is equals to 4. Therefore, the range is from 0 to 4. As you can see in this set of data, there is no value which is less than 0 and there is no value which is greater than 4. And that is what the definition of range is. Now, before diving deep into the concept of range of integers, it is better to get into some prerequisites. And one of the prerequisites that we have to pass through is knowing decimal number system. In our day-to-day life, we use decimal number system for many purposes. Maybe for counting purpose, or maybe when we need to quantize some information like 2 apples, 30 bananas, and so on. Decimal number system is human understandable number system and is also called as base 10 number system. Base 10 simply means the range of number that we are available with is from 0 to 9. Let's take one example of a decimal number. We pronounce this number as 568 instead of simply saying 568. Have you ever wondered why do we pronounce it like that way? Because in reality we have numbers ranging from 0 to 9. And if we want to represent such a large number, we have to multiply each digit with their respective place values. Here place value are starting from the rightmost end and it is 10 raised to the power 0, then 10 raised to the power 1, then 10 raised to the power 2 and so on. When we multiply 8 with 10 raised to the power 0, we get 8 only. When we multiply 6 with 10 raised to the power 1, we get 60. When we multiply 5 with 10 raised to the power 2, we get 500. And now, in order to get the desired result, we add them up to get 568 as our result. Isn't that easy? Okay. But this is not something that machine could understand. It has its own number system called binary number system. Binary number system is machine understandable number system and is also called as base 2 number system. Means range is from 0 to 1. Only 2 numbers. As you can see here, I have written a 4-bit data 1100. In this case also, each digit must also have some place values associated with them. Because binary number system has base is equals to 2, therefore starting from the rightmost end, we have 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3 as their place values. And if you want to represent this number in decimal, then you have to follow the same method that we had adopted in case of decimal number system. That is, multiplying the digits with their respective place values and finally add them up. As you can see here, if I multiply 2 raised to the power 0 with 0, I get 0. 2 raised to the power 1 with 1, I get 0. 2 raised to the power 2 with 1, I get 2 raised to the power 2, which is equals to 4. 2 raised to the power 3 multiplied with 1, I get 2 raised to the power 3, and that is equals to 8. By adding all these numbers, we get 12 as our answer. Now what would be the range of 4-bit data? As we know, to calculate range of any number, we have to know its minimum as well as maximum value. For 4-bit data, minimum value is equals to 0 when all digits are 0 and maximum value is equals to 15 when all digits are equals to 1. You can get this value by using the same method by multiplying each digit with their respective place values and finally add them up. In this case of maximum value, you are multiplying 2 raised to power 3 with 1, then 2 raised to power 2 with 1, 2 raised to power 1 with 1, and 2 raised to power 0 with 1, and finally add them up to get the answer 15. And here, because all of them are 0, multiplying it with their respective place values would finally give the answer is equals to 0. Therefore, range of 4-bit data is from 0 to 15 only. But there is one more formula available to calculate the maximum value, and that is 2 raised to the power n minus 1. Suppose you have a 32-bit data, then adding all these place values and multiplying with their digits is quite difficult. Then this formula is quite handy to apply. Here, by replacing n is equals to 4 for 4-bit data, you get 2 raised to the power 4 minus 1, which is 16 minus 1, and that finally gives the value is equals to 15, which is our maximum value. Let's calculate the range of integer. If in your machine, the size of integer is of 2 bytes, then the unsigned range is from 0 to 65,535 by applying the same formula for calculating the maximum value. By replacing this n with 16, you get 2 raised to the power 16 minus 1, which is nothing but 65,535. Usually, we also have to represent the negative values, and that we can do with the help of 2's complement representation. We actually have 3 different representations to represent negative numbers, and they are signed magnitude, 1's complement, and 2's complement. But in most of the computers, 2's complement representation is used. 2's complement ranges from minus 2 raised to the power n minus 1 to plus 2 raised to the power n minus 1 minus 1. If you want to know more about 2's complement representation and other representations, then you can refer the NASO Academy playlist of digital electronics here on YouTube. Here you can see minus 2 raised to the power n minus 1. By replacing n is equals to 16, I get 2 raised to the power 15, which is minus 32768, and plus 2 raised to the power n minus 1, that is 2 raised to the power 15 minus 1, that gives 32767. On the other hand, if your PC supports 4 bytes integer, then unsigned range is from 0 to 4294967295. By applying the same formula for the maximum value, signed range can be obtained by using this 2's complement range. That's it. See you in the next lecture. Bye-bye.